Hello everyone, welcome to ashatech.com, your engineering sciences channel. In this video, we are going to discuss how you can numerically solve an ordinary differential equation in Matlab. Now we are going to start with an example of a radioactive element decay curve, and that is the ordinary differential equation of first order. Let's define the ordinary differential equation using the function handle as an example. So we are going to say ODE is equal to at, we know it is going to be a function of t and the solution is y. In other words, y is a function of t. So this function handle has t and y, but we know it is going to result into the formulation of y, or the solution which is y, as a function of t. So we define our differential equation as negative 0.5 times y. Okay, we proceed and now define the initial conditions. We have to define the initial time and we are calling it t0, which is equal to, we are saying it is going to be 0. We are starting at 0. That is the initial time. Then we also look at the initial quantity of the radioactive element, which is y, and y0 or y0 or y at t equals 0 is equal to, let us take 100, maybe 100 kilograms. Okay, we suppress it so that it doesn't come out in our command prompt as we run or test the results. Then we also need to define the range of time. So we need to define the range of time values, and let us use t-span. T-span equal to, we are taking it as a row vector from 0 to 10. Okay, we also suppress our t-span. Then we are going to use using the ODE 45 that operates on longitude 4 and longitude 5. They are all combined in one method, and to provide at least better results of solving a differential equation numerically. So we are going to use the ODE 45 in Matlab to solve the equation numerically. So what do? We are going to first of all know that it outputs y as a function of t, having solved this ordinary differential equation, and that solution is going to be ODE 45 into our differential equation is ODE. So we are going to say solve that ODE using ODE 45 with the range of values of t, which is t-span, then with also the looking at the value of y0, and the value of y naught is, we said it is 100. So we are going to say y naught. So we cross. Then after telling the ODE 45 to solve this differential equation, we are going to visualize the results by plotting. So let us say plot we want to plot t on the x-axis, then y on the vertical axis, and you want that plot to be blue. Okay, blue solid line. And we also want the line width of 2. Let us take an example of 2, then also suppress our results. Then we can say x label. First of all, we put in time values or time t, and we close. We can also go ahead and put in y label, and we can say amount of radioactive element then we can say title, and say it's a numerical solution of the radioactive decay equation. Okay, we can run and we see what happens. Okay, when you run, this is what happens. We have our graph plotted that is showing us how the decay of this radioactive element is happening with respect to time. The initial amount is 100, and we see as it approaches the t-axis, it goes, you never know, it will come to at a particular time it will come to 0, but we see it continues and is asymptotic to the x-axis, and this is the already interpreted results, because we know the decaying of a radioactive element follows an exponential decay curve like this one. Let's go backward to our file. Of course, we had to first save it as a decay curve.m. This is a script that we had already saved, so we save it so that we can always access it. Then we can maybe modify. We modify and maybe we want to put grid on, and maybe also suppress the results, the numerical results of our ODE. Then maybe we can also say let this plot be dotted or becomes a line with a dot, like that. And maybe let us say it's in cyan. Then the line width, we change it to 4. Okay, let's run our results. So you can see our modified plot of this numerical solution is looking beautiful. Let's go back and add legend. So let's add legend, and in the legend we are going to put we can put that this is a decay curve. Decay curve. We run. So this is how it looks like, and we have solved the differential equation numerically, and we have followed the steps. First of all, by defining the differential equation, then giving it initial conditions, giving the range of time values, and also calling the ODE 45 as which is a differential equation solver in Matlab to solve this particular differential equation, and using the plot to visualize our results. Thank you so much.